Well done, John. Thank you very much indeed. So I'd like now to call on Charlie Coakley, Dawn Meats, Group Environmental Sustainability Manager. Charlie has spoken to us before, but Dawn have set themselves some extremely challenging targets, and look forward to hearing from Charlie and progress and where they're at on their journey to date. Over to you.
Thanks, Conor. Good afternoon, ladies and gentlemen. Thanks, Ronan, for inviting me here today to speak on behalf of Dawn Meats, and really just to share some of our experiences in sustainability and energy management today. I'd like to talk to you briefly about Dawn Meats and sustainable practices, focus in detail really on our starting point for us really, and our initial approach to energy management, but also sustainability, and how that, I guess, evolved or developed into what we have today. What we found works well for us across all our sites, some of the technology that we've installed, and also some of our achievements and challenges moving forward. Just briefly first, a background on Dawn Meats. Dawn Meats is a family business established in Waterford in 1980. As a family business, it remains true to its farming heritage, with a continuous focus on quality meat products for some of the most discerning customers worldwide. And over the last 30 odd years, the company has evolved to become a highly integrated production, sales, marketing and distribution operation, as I say, for some of the most discerning customers worldwide. And Dawn Meats are at the forefront in providing sustainability initiatives which seek to support the commercial but also the environmental sustainability of food production from farm to fork. As I say, Dawn Meats has taken a proactive approach to sustainability and in its farmer supplier base. And back in 2009-10, we formulated a sustainability plan, Sustainability Today for All Our Tomorrows. And this really was the starting point of our sustainability journey, and our main focus was on energy, waste, water and supply chain. And our Board BIA Origin Green Charter is very much aligned with our sustainability plan, and moving towards sustainable practices is core to Dawn Meats' business ethos. We recognise that by addressing sustainability in our business, we provide a better quality product. We also recognise that sustainability provides environmental benefits not only for us, but also for our supply chain. Sustainability is a very wide topic. It covers many aspects of a business. Topics are very diverse, ranging from ecology, profitability, health and safety, etc. Some people call sustainability the triple bottom line, or people, planet, profit. And for the purpose of today, I'm going to focus in on one aspect, and that's namely energy efficiency. Back in the late noughties, early 90s, with the rising energy costs, the question was asked, as in any company, well, what can be done to reduce these energy costs? And this really initially focused our initial approach to energy management and sustainability. We recognised that improving our energy efficiency improves our carbon footprint and associated impact on climate change. And our initial approach really to energy management was to set up a group-wide study comparing energy consumption across all of Dawn Meats sites. And from that then, the largest consumer was targeted for audit. And really the purpose of the audit was to try and share the best practice that was currently in use across the sites, but also share current knowledge on BAT. And initially, yes, we found we had some success in reducing the efficiencies and consumption, in improving efficiencies, and in reducing consumption on the sites targeted. But we did, however, find this initial success hard to maintain long term. And we found the sites to be on somewhat of a roller coaster ride. On the sites, as I say, we found it hard to maintain this initial success long term. On the sites that were re-audited, we found that the same issues kept arising, or generally what I found is, well, here comes Charlie again, let's get that last audit out again. And we believe that this effect was mainly due to the absence of a formal energy management system, John alluded to 50,001 there, and also that energy management and responsibility for energy management lay with one or two, or as opposed to the site as a whole. Moving forward and through engaging and working with energy technology providers, a formal energy management system was set up at a site level. And responsibility for review and analysis of energy on the site was given to the site. And from this, we found that ideas started to flow from the site. Teams were set up on a site level that were multidisciplinary, comprising of production, technical, financial, engineering and quality. Objectives were set for each of the sites rather than just the larger consumer. And I guess it's through the site teams that we work to try and raise energy efficiency, but also a sustainability culture at a site level. And I guess we see the site team as the vehicle to do this, to raise the energy efficiency culture, but also maintain it and sustain it. Sorry, excuse me. And it's the setup of the site teams give ownership of energy management, but also sustainability to the site rather than just corporate management alone. Ownership of the energy management and sustainability now belongs to the site team, rather than previously just one or two. And I guess this allows for a top-down but also a bottom-up approach to energy management and sustainability. As I said earlier, teams are multidisciplinary, comprising production, technical, financial, quality, etc. And this multidisciplinary aspect allows focus on energy and sustainability from various viewpoints, whether that be cost benefit, environmental benefit, practicality, and even feasibility. The setup of the teams have facilitated knowledge of how and where energy is used across the sites. And from this, we found that ideas and innovative ideas started to flow from the site. I see corporate role now as more of one of providing technical backup and knowledge of that. And we believe that this site team approach not only helps develop, but it sustains and maintains an energy and a sustainability culture at a site level. The energy audits are now conducted annually and have been renamed energy plans. An energy audit is carried out at the start of the year in conjunction with external help. The audit formed the basis of the energy management system, which incorporates, the energy audits form the basis of the energy plan, which is then incorporated into the environmental management system 14001. Initially, we targeted low-hanging fruit, and the plan sets out projects for the year with respect to energy efficiency, but also sustainability. Responsibilities and deadlines are identified for every project. If the review and analysis is done every 6 months to 9 months, depending on the type of project, and if a new deadline is agreed, at the end of the day, we all live in a real world. If a deadline is set for a project for whatever reason, it may move, and a new deadline is agreed. And the plan allows to keep energy efficiency, control of energy in a structured and organised manner. The plan, and we believe that this approach sustains energy efficiency. And also, as new equipment is installed, you can actually see a step down in the curve there on that graph there, but I'll actually show it in a real term energy graph from one of the slides. And we believe that focusing on energy in this way avoids the roller coaster ride or the seesaw effect with respect to energy efficiency, but also sustainability as represented there in the red dotted line in the background. And it's through the site teams that we work to raise energy and sustainability throughout the sites. And I guess, as I said previously, we see the site teams as the vehicle really to maintain, sustain the energy efficiency and sustainability culture. There on the screen, one way to promote energy efficiency across the sites is through poster campaigns. Sorry, excuse me.
Sorry, Roland, could you just maybe get Charlie a glass of water?
Yeah,
yes,
no, it's one here.
Yeah. Oh, you have one there. Okay, great. Thanks, Roland.
Thank you. On the far right there, you can see as you look at it, that's really just to turn off lights. On the middle one is what we have quite a lot of freezers and fridges throughout the site. No different than your fridge at home. I mean, you have a light on and keep the door closed. Obviously, keep the refrigerated air within the room. And on the far left is again, turn off photocopiers, PCs, etc. But also what the employee can do at home to improve energy efficiency. This project is on the 2 Degrees website. It was given to 2 Degrees, gave us an award for the use of NASA technology to recover heat from a flue gas. And the principles of the heat exchange were first developed by NASA to cool nuclear power packs in space. And within that unit there's single independent pipes, and that allows the transfer of heat from the hot gas within the unit across to the water, and then we use that for sanitation purposes within the site. On one side of the heat exchanger, as I said, you have hot gas, and the other side hot water. The single independent pipes within the heat exchanger prevent cross-contamination, but also eliminate taking down the whole unit. If one pipe goes, you can just isolate that pipe without actually taking out the whole unit. And we believe we've set a new benchmark in proving that this pioneering technology is effective and safe within our industry and other similar industries. Transferring the knowledge we gained from that site, we moved to another site, and this is our Ballyhonus site. Again, SEI gave us, John is here today, SEI gave us the Innovation Award for this last year, and it's the longest industrial district heating system in Ireland. It's the first implementation of that NASA type of technology on a cooking process. And really, when we went to that site, we originally were looking at putting it on the boiler stack. And we had a cooking process on that site, so we said we'd give it a go on that site. Now, we had for years tried, but unsuccessfully, to reclaim heat from that cooking process. And when we put that, as I call it, the NASA type heat exchanger on the cooking process, we were really, I suppose, taken aback by, number one, the amount of heat, and also the volume of water that we could get from the cooking process. So I guess at this stage, the idea was born, or the concept was born, to pipe it a kilometre to a sister site which has a large requirement for the hot water. Now, we're in unknown territory at this point. We had no reference site for a project like this. It was by no means an easy task. We had to cross a river twice, go through a bog, but also go under a railway line. The engineers on the site that were going to thought were somewhat off our heads when we told them we were going to pipe hot water down to the site. But on the screen there you can see actually the industrial district heating piping. It's the one in black. And within that you just have 2 pipes, one going up and one coming down. The 2 red pipes there are electrical conduits. It's not every day that you are going to be digging a hole or a trench between a kilometre between 2 sites. So we took the opportunity to run some electrical conduits. And on the far right is just the NASA type unit itself. Here you can see a live screenshot of the system itself. Just briefly to go through it with you. Tank 2 is the middle tank. We're pulling in some water from your ambient water from on that side from a well, and raising it up to between 20 and 30 degrees through the refrigeration heat recovery. From there we're piping it up to the cooking process, which is the WP economizer, and raising it up further to 78 degrees. Now on the screen there it looks quite near, but that's actually a kilometre from the site, literally 990 metres. We measured with that thing that you measured, that little wheel you go on the ground. And there was pipe back down to the other site for storage on the other site, for use, by the other site. Here you can see the thermal energy graph from that site for phase 2 and phase 3 commissioning. Phase 2 commissioning was the trenching of the pipe, and phase 3 was the balancing of the hot water requirements, just to meet the production of hot water requirements with the requirement on the second site. Quite a few integrational issues on that site. This was new to us. We had no reference site in Europe or even further afield. Simple little things like, okay, the guys on the site that are receiving the hot water, they're used to running the boilers, flicking it on when they want. Okay, guys, you actually don't need that second boiler. Turn it off and leave it off. Now you're also trying to get a hot water system that's being piped down to talk to the boiler system. So at the end of the day, personally what I found from that project is that if the engineering and science is sound behind something, you just stick with it and you bed it down, and I guess don't lose faith. It's also really demonstrated for me one of the basic principles of thermodynamics, in that energy is neither created nor destroyed, but just transformed from one form to another. And for the site there, it's providing a renewable energy strategy for their hot water. They're not exposed, I guess, to the fluctuations in market price in oil or gas. And you know, this project can be replicated not only in our industry, but in similar industries worldwide. And if you don't have an outlet for the heating, you could form a collaboration like we did with a sister site, or even indeed provide heat into the local community.
Sorry, Charlie, a couple of minutes.
Okay. Sorry guys, I just have to flick through these since Connor is telling me to hold on. Moving to another site, this is a heat pump. If I'm speaking too fast, so you can talk to me afterwards. But on the left there is a heat pump. Again, in the middle there you have the NASA type unit. We have a cooking process on that site. That's just a picture of the two tanks, basically the heat pump, refrigeration, heat recovery, and the NASA type unit, raising the water up to about 25 degrees or thereabouts, and then the heat pump pulls it from there and into the second tank. I guess we were talking about boilers earlier on there and efficiencies of boilers. Your boiler, in your 90% efficiencies, you're talking about 0.9 of a COP. The heat pump has a COP between 5 and 6. So they're really your order of efficiencies. Here is just a live screenshot of the NASA type unit on that cooking process on that site. Ambient water coming in at 8.6 degrees, steam at 95. We have two temperature probes there. We're trying to reach for 55, and that valve there will open or close depending on the temperature that is seen at the two temp probes. Again, here is just a live screenshot of that in play. Due to time, I'm not going to go through it with you. Thanks, Connor. Again, here is a thermal energy graph for that site. We're seeing approximately a 50% reduction on that site. Again, integrational issues, there's no magic wand. Main integrational issues there on that side was trying to get a heat pump to talk to a refrigeration system, but also talk to a boiler system. Again, this is a heat pump we installed on another site. And the reason that slide is there is really just to show you that each site is bespoke and it's going to be slightly differently set up depending on the site. Again, moving into the supply chain, and Board B and our Green programme has really helped us to build on our sustainability plan. We're now not focused, our original plans were just focused on energy, waste and water, and that Origin Green has helped us embed sustainability into all aspects of our company. And it has allowed us to take a less insular approach to sustainability. There are areas within our Dream programme such as biodiversity and some social side. And I guess at the start this posed a real challenge for us, but also an opportunity. And on this particular side and on this slide, we looked at fuel poverty in conjunction with the SEI and housing an elderly unit, an elderly using comprising of 26 units for the elderly. There was attic insulation, cavity wall insulation, CFL lamps and stoves. Sorry, I'm just rushing through that.
All right, yeah, very valuable.
And finally, again in the supply chain and with Origin Green, we have a dedicated facility in Waterford. And we originally wanted to look at something innovative in terms of water pollution control. I guess the trend over the last 100 years or so has been more towards concrete and steel. And here we looked at an integrated constructed wetland. And in that it's providing total water treatment, not just polishing of our effluent. And in building it, we just went a little bit step further and built an eco park around the wetland, planting native shrubs, trees, etc., to provide food, shelter for the local wildlife, but also wildflowers and grasses to promote the pollinators within that area. We all are aware that the bees are in steep decline around Europe, and man's intervention is required to build up those populations, but also so that our food production system remains productive in terms of crops. I'm not going to go through the summary. And finally, in conclusion, we have achieved a lot. We still have a hell of a lot more to do. The agricultural food industry is the largest global industry, and as such has a significant environmental and sustainability contribution to make. The question is often asked, and I'm often asked, well, will sustainable practices sell? We believe that question should be, can we actually survive without them? Thank you.
Well done, Charlie. And a very interesting presentation. I'm just looking at some of the graphs, and I'll maybe ask you a few questions.